Thank you very much for your time. This is basically the first meetup of, I hope, many. Me today, I'll just do like an intro, and then we have Jure and Tomaz who did prepare something. So I just wanted to like talk about things that kind of perplex me about this stuff. So if you think about what the data center looks like or did look like, so 50 years ago, it was like this massive machine as big as this room, and the actual box caused malfunctions, which is insane. And then basically smart people, learned how to make the machines smaller and network them. So the data center was a few machines, maybe possibly some racks, and that was kind of it. The only variable really was the network. And then people introduced virtualization, and this caused like an order of magnitude of complexity to be like created out of nowhere. So the same hardware, but the things that you need to manage was multiplied by like many times. And this is where things started to kind of change really for the industry as a whole. So how do you manage that? And then obviously all the rage right now and for a few years now is Docker and containers. So now we are obviously going to another scale of things. So instead of 50 or 100 virtual machines, you can have thousands of containers. So it's a slightly different problem set to tackle. So, but I don't know about you, but me, I don't have this perfect data center where everything is a container and it's nicely managed. Mostly your infrastructure is always in like a constant flux. It changes. You may have some legacy stuff on VMs, you may have some containers, and it's challenging to deal with all of them together as well. So you don't have one thing to handle. And then if you're unfortunate as I am, you have another problem. So not only one data center, you can have multiple data centers with different regions, all running either VMs or containers or stuff as a service. So you may have Elasticsearch as a service, not as a thing that you manage, which is great, but then you need to somehow account for that and know about that. So the data center right now is basically one or more physical locations and a lot of the services that kind of support that setup. So it's not just you install that VM and know how to do a golden copy and you're golden, right? It's a bit more complex. So how do you deal with that? I have no idea. That's why you're here, so that I can learn something from you. And if you just think of Docker, there's this huge array of things that some seemingly do the same thing, but for some reason, one is better than the other. So, like, how do you deal with that? Like, I don't have time to research and implement everything. Like, it's too much. So this is where this meetups comes into play. Basically, I don't have, how should I call it, a lot of experience with DevOps. I certainly am enthusiastic about it, but I wanted to prepare this meetup to basically share what I'm doing, what we are doing, and to kind of open up and connect the community around this so that we can share and learn from each other. So basically, what I wanted to do in the next few months, or let's say a year, I wanted to kind of through talks cover everything that there is to cover if you're running slightly larger enterprise. So how do you provision stuff? Loads of providers there. How do you, what OS do you run? Why would you, what's Rancher OS? How do you configure stuff? Is Salt Stack really the next big thing? Why is Ansible not good enough? How do you schedule? Do we even need this? Like Mesosphere just seems like a massive thing to run and to maintain. Where's the value if I have 3 developers and this app that's going somewhere? Monitoring. New Relic seems expensive. Like, is it really that good? Can I homebrew something? I don't know. Databases, the same thing. So why would you choose something that's managed versus you managing everything? So then you need to consider all the assets, right? So there's passes and IASs, and what's the difference? Where can you use some, where not others? And basically what I'm saying that we have this massive increasing complexity in our industry. So whereas at like 3 years ago, you were really proud that you had this 183 days of uptime on your server. Now it's kind of like you're still looking at uptime. Like, don't you change your containers like just for the kicks of it? Because you can. So I don't think anyone has all the answers, certainly not me. But I hope that we can all learn something from each other. So Slack me if you want to share something, either lightning talk or anything else. Today we'll listen to Tomaz about Consul and Terraform, and Jura about ECS. I'm sure that those things will be great, some great tools. So yeah, please enjoy.
Okay, so hi. My name is Tomaz Strukelj. I do systems operations at DLabs, and lately I have been playing with two tools from the HashiCorp stack, HashiCorp toolset, which addresses the complexities of the data center. It's a HashiCorp solution to the data center automation. So Terraform is an infrastructure configuration tool. It provides infrastructure as code, which enables versioning, code review, and reusability. Code review here is a big thing, because until recently only application developers were using code review. It eases the mentoring. The knowledge sharing is easier. So it's a good thing. So for the last a year, also operations guys were able to do code review on GitHub in a browser. Then the next thing that it provides is execution plans. So it provides a test run, a dry run, so you can see what changes will be made on the infrastructure when you change something in the Terraform configuration. It provides a resource graph, which gives you an insight into the resources you're using at the service provider and what are the dependencies of those resources. It provides change automation, which means that you can make a small change in the configuration, but that small change results in 10 changes in the final infrastructure. And the Terraform has a plugin-based architecture, which means that if you have a use case that is not covered by the providers that are bundled with Terraform, you can develop your own plugin to solve your use case. So infrastructure as code. Terraform uses, you can configure Terraform in two formats, JSON or HCL. HCL is a custom HashiCorp's configuration language. It enables, so Terraform enables you to use interpolation using internal functions, and you can define variables. This is one small example of defining a variable. This is a dictionary variable. It just maps Datacenter to an image, to an AWS image from which you boot up an instance. And the second one is a resource of type AWS instance, so it uses Amazon provider. And here are two lines are highlighted. The first one is how you use a dictionary variable to assign it to a field. In this case, it's called AMI. Sorry. And the second interpolation is a runtime interpolation. So before you create an instance, you already have to have the network set up. So in one single Terraform run, everything can be created in a certain correct order. And during this processing, Terraform creates a subnet, a network. It gets the ID from the subnet ID from the service, from the AWS, and then uses the service here to configure instance to use this subnet ID. So how does Terraform compare with other tools? So for example, how does it compare to configuration management tools? So here, code represents infrastructure resources. In configuration management tools, it doesn't represent, it just kind of, you say what you would like to change or be done. But here, if you remove code, if you remove some code in the configuration, the result is that you remove the resource on the service provider. So there is no explicit resource deletion. For example, in Ansible, like in any other configuration management tools, you have to explicitly define deletion of a resource. So what about comparing to Amazon CloudFormation, which is a tool specifically written for this, but it has a few drawbacks. It uses just JSON, which is not quite easily readable for humans. Terraform is cloud agnostic. CloudFormation is just for Amazon. So with Terraform, you can combine multiple cloud providers or other services or tools. And none of these tools support planning phase. So you want to know what changes will be made when you change the configuration. For instance, in CloudFormation, you have to check everything. You have to reason about everything, because when you deploy that, when you hit deploy, you may break production because you missed something. So these are the basic commands. Graph, so Terraform graph for showing you the resources dependencies. So how all the resources like instance and networking and load balancers, RDS, how are these all connected together and what are the dependencies between these resources? You can you can do a plan with the plan command. It shows you the changes that will be made the infrastructure based on the changes you did inside the code. Apply just deploys to the infrastructure whatever you have set up in the configuration. Shows you the current state of the internal state file that Terraform manages. It's used as a cache to speed up commands. And then the powerful command destroy. A good use case is when you're testing you need some cluster or whole stack of services that you're testing on. And after a few hours you've done testing, you need to destroy everything. Here you have one single command to do that. These are two examples of the execution plan. The first one is just some tag rename. So the tilde is highlighted, which means that there's going to be a change in a field or in a part of the resource, but the resource is going to stay there.
Can we turn down the lights so we can see the slides?
Yeah. Oh, sure. Sorry. Do we have the switch? Okay. Great. Okay. So the second example shows you how a minimal change in the configuration can result in a number of changes in the infrastructure. So here we are changing just the address of the subnet, and this change results in the change of 3 resources. So the subnet that we have changed in the configuration, the routing table, and the instance has also be changed. Okay, I've talked about, I mentioned that it uses a plugin architecture. So it provides many providers. So a provider is a plugin that interfaces with the external service through their APIs. And we can group them in 4 groups. So it's all the AIs, so ASs, how Damjan said, and the specific tools, individual tools, like you can manage MySQL, Postgre. I mean, you can manage a short list of things, but the ones that you need to bootstrap a resource. So when the providers do all their stuff, you can define provisioners that initialize those resources. Mostly you would use some configuration management tool to initialize the instance. Okay, currently Terraform doesn't know about the resources that you didn't start to configure it in. So it doesn't pull the resources that are already, let's say, on Amazon. Terraform uses a state file, which is a text file, so you can edit it. You can just manually add all those resources that you have on some specific service provider. That is one solution. If there are not so many of the resources, you can do that. But most preferable is to use some other tool. For AWS, there is a solution called Terraforming, and it generates the configuration file and the state files. So, for example, for instance, that you already are using Amazon, you have a few instances, you use load balancer, DNS, you have DNS configured, you use RDS, CloudWatch for monitoring, and you use this tool. It imports everything into Terraform, and from that point on, you can use Terraform to manage your whole cluster. Any questions?
can you calculate the back rollback?
So when there's an error, so when in the creation of the resource there's some failure, the situation stays as it is until you run Terraform again. So when you run it again, when the resource is in the error state, Terraform taints it in its internal state file, so it knows that that resource wasn't created successfully. And you can iterate that. You can make many iterations to finish this. But if you can't finish it, then Terraform knows about that resource being tainted, not completely successfully created, and it will destroy it.
It will destroy it? What happens if there is the state in an error and like, isn't there an option then that if I rerun it like 100 times that it will eventually something will break? Or
no, because the state stays the same all the time.
okay. Thanks.
Okay, then I'll move forward with the second tool that I was playing with, called Consul. So Consul is auto-discovery and central configuration management tool for the infrastructure. So it's also part of the HashiCorp stack. It's a distributed, highly available data center aware service that features, so the main one is service discovery, health checking. It provides a key value data store for central configuration, and it features watches and events. You can trigger your own events. This is a web interface, default web interface that comes along. It's quite useful. So it runs as an agent in two possible modes. So it can be a server mode or a client mode. In server mode, these agents form a cluster. So recommended is minimum of 3 nodes to make it high availability. Preferable more. And these servers or these agents handle the auto discovery and the key value store. They store the key value store itself. Then there are clients that only fetch data, and all these agents are connected between each other to make it to make the high availability. This is an example how to list the members in a terminal. Here we have one server. This is in development mode, and 2 clients. So the first thing is service discovery. It provides the dynamic discovery of healthy services. There are 3 ways to interface with Consul. First is with DNS, which is legacy friendly, which is the simplest solution. No application changes are required, but it's very basic. You just get the address, and additionally you can fetch the port on which the service is registered on. The second one is through HTTP API, through which you can manage everything in Consul. Not only fetching data, but setting configurations, adding services, and health checks, and changing the key value store. And then the third option is using Consul template, which is similar to convd, if anyone has used it. So it provides arbitrary application configuration using Consul. This is an example of using DNS to do service discovery. So you have 3 parameters here. Basic service name, with which the service is registered in Consul. Then you can search over tags that are registered on the service, and over the data center, So you can specify from which data center you want the service endpoint, so the service node or address. Because each data center can have, you can have cluster in each data center, and these clusters are connected together, so they know about each other. And then here's the example of using SRV DNS query to fetch the service port. So not only you can fetch the address, you can also fetch the port on which the service is registered. This is same using the HTTP API. So you just make a request to an endpoint. In this case, it's catalog service and the service name, and you get a list, a JSON with a list of nodes on which this service is registered. Here's an example of listing the services together with the tags. And here's the third option of using Consul template. This is a Go templating engine. In this case, we have an Nginx upstream configuration block. And with this template, we fetch the list of the nodes together with the ports that have the service called web registered on and which is healthy. So Consul template will create this configuration below. So if service on the first node or the node itself malfunctions, as soon as Consul notices this Nginx configuration file will be changed, and Nginx will be reloaded, and this happens in a matter of seconds. So the additional level of auto-discovery is health checking, because what's it good for the application if there's a failure in the service and DNS and Consul still returns that address? It's no use. So Consul removed the unhealthy nodes. You have a few check types. So the first one, script, is the same. It's the same checking of the exit code as the Nagios uses. So if the exit code of the script is 0, then it's okay. If it's 1, it's warning, and all above, it's critical. The other ones are internal HTTP check, then raw TCP check, Docker script check, which is basically a script check, but it's made inside of a Docker container. So all these 4 are active checks. You can also have a passive check with a TTL check type. So we define the time in which an external health check should ping Consul. If it doesn't ping in the specified time, then the Consul will change the state of that service to unhealthy. This is an example. So one service is down, or the whole node is down, and as soon as Consul figures that out, requests for this service will respond. So the response to the requests will contain only 2 IPs, not 3 anymore. The third feature is this key value store, which is distributed in high availability. So you can interface it with either HTTP API or using Consul template. So this enables dynamic configuration. Here are 2 examples how to add a key value to the endpoint of Consul and how to fetch the raw value. This is a web interface that comes along with Consul. It is really simple, but it's useful. Okay, the fourth thing are watches. So you can put a watch on any resource inside Consul. So it can be either a service status, node status. You can register a handler to this watch, and whenever the change happens, this handler will be called. You can also trigger your own events. You can create an event handler with a specific name, and then you trigger this event by providing the right name of the event handler, of the event being registered, and you can fire this event or either throughout the whole cluster. So all the nodes that have event handler set up will respond to this event, or you can trigger it, you can fire it only to some specific nodes and services. Yeah, and any questions about Consul? So in the next slide, Jure is going to show you how he uses these both tools in the real-time example. I mean, real-life example. Yep.
How difficult is it to maintain a cluster of Consul nodes? I mean, it uses consistency, and that usually brings a lot of problems with network partitions and such. Did you experience any difficulties, or? So
Consul is different than etcd, for example, because it alleviates, so it handles network partitioning issues because each resource has its own counter, and that counter goes always up, and in this way it can handle network partitions better.
So it doesn't fall apart when partition happens?
Yeah, that's correct.
Or does it primarily?
Well, it's if it can, yes, it helps. So it solves itself. But I mean, we didn't have any issues with this yet.
How many server nodes are you running?
3.
I have an answer for you. It has multiple consistency modes, so you can actually set, like, the default is fairly consistent, but you can also set consistent, which will always check with the master. But yeah, it's pretty solid.
Cool, thanks.
Okay, so then, Jure.
Well, can we make a short break so I can...
Oh yeah, sure.
Yeah.
So a short break. How much? 5 minutes.
So if you're dying for a beer, you can go fetch a beer.
I actually have another question. So did you have any, I read somewhere that it can be problematic to use the because of, I don't know, stale records and stuff like that. So they in real time or TTL is set to 0. How does it do
Ja bi mogu to že zaznati. Mas eu estou rezando. Ja. Kaj? Kje? Ja, se imam v bistvu v high availability, tako da imaš pač itak failover, ne? Mislim, redundanco imaš, ne? Ne, eden je kot redundanca, en ti lahko dol pada, ne? Ja, node proče dol pada, ne? Nič hudega, se imam še vedno dva noda, kjer laufate Consul gor in dejansko se potem spet election zgodi, ne? Tako. Tako, oziroma že dosti je probleme, že če dva odletita, ne? Lahko, ne? Ali že sem neke probleme sem ja, drugače lahko 5 nodov laufaš, pa imaš v bistvu 2 redundance, kar je kar cool, ne? So, ja, se bom zdaj tole probo koristiti, kaj. Alrighty. Boljš? Isto direkt, ne? So is everybody here? So, hello, my name is Jure Žvelc and I'm a web developer at D-Labs. And I'm not a DevOps expert, but I hope that I will provide you some useful information about Amazon ECS and Docker. And today I won't go into details how stuff actually works because you have plenty of documentation online and videos, but I will focus on my infrastructure and how I do deployments and how I have resolved certain issues with Amazon ECS. So, this is the roadmap for today. So, why containers? Containers provide portability and isolation. We can easily build and distribute images which contain all necessary data for execution. For example, we don't need to build assets on our production servers. We can just pull the image and execute it. I mean, we can run a container, so we can spare on some resources. It's also possible to resemble production environment locally, since containers with same configuration will behave same across different environments. That means that you can actually run some kind of a production preview locally, so you can see how will your web application perform and how will assets get compiled and so on. All right. Well, I've been using Docker for development for some time now, and it's been pretty shitty before 1.9 version because it had some serious issues with volumes. And with 1.9, a new volume API was introduced along with named volumes. Previously, when you removed a container, you came up with a dangling volume. And when you created a new container, a new volume was attached. Well, this was really a problem unless you mounted a volume directly from the host. So named volume solve this and can be safely reattached when you bring up a new container. Docker 1.9 also comes with networking improvements. Previously, the only way to communicate between containers was through container linking. This is now considered as legacy, and DNS-based container discovery is used. Also, Docker Swarm is now considered to be production ready, and yeah, they really made a lot of bug fixes. Why I'm telling you this? Because Amazon is currently running 1.9.1 version of Docker, if I'm correct. So, now I will tell you some things about development with Docker. Well, great thing is that it's really easy to set up and manage multiple environments. So, for example, once you have development environment ready, it's really easy to extend it and reduce it to simulate production environment. So, if you're using Mac, all you have to do is to download and install Docker Toolbox and use Docker Machine to provision your development box in which you can then run your containers. It's really easy to define and manage your containers with Docker Compose. In Docker Compose file, you can define which containers to run and how to run your containers. So, which command you're going to execute, which volumes you're going to use, which ports you're going to expose, and so on. Yeah, development with Docker is currently really great. I'm using it. It's fast, smooth, and very easy to configure. So let's move on to deployments. So not long ago, a client asked me to explore and evaluate Docker deployment options. Well, first I checked the official Docker solutions. For example, Docker Swarm is a native Docker clustering solution, and the best thing is that it's fully compatible with other tools from Docker Toolbox. Do you know what is Docker Toolbox? I don't know if I have mentioned. Well, it is a tool set and contains Docker Compose, Docker Machine, Docker Engine, and Docker Swarm. So you can work with these tools to orchestrate your development and production environments. This means that you can tweak your development Docker Compose file and manage your production environment the same way as you manage your development environment. It's also very flexible and can be configured for high availability setup. Well, I've also tried Tutum.io, which is now known as Docker Cloud. It was really easy to use it, but it's not that flexible and it's not compliant with the Docker Compose specification. They actually call those files service stacks. Well, a great thing was that you got 10 free private repositories during the beta, which is now not the case anymore, and Docker Cloud is now quite pricey. Well, for me, paying for around $15 for managed instance is not so small amount, especially if you manage a huge amount of container instances. And the last one is Docker Universal Control Plane, which is on-premises solution for businesses and should also be fully compatible with Docker Toolbox, but I actually haven't tried it because you have to sign up for trial. So, since we were already using AVS for production, it makes sense to use Amazon ECS because it can be easily used with other AVS services such as Elastic Load Balancers, Virtual Private Cloud, CloudTrail, and so on. Yeah, I already mentioned that Docker is now running 1.9, ECS is running 1.9 version of Docker. And Amazon ECS is consisted of following components. Cluster is a collection of container instances, which are actually EC2 instances running Docker daemon and Amazon ECS agent. Task definitions can contain up to 10 container definitions and are used for running tasks. Tasks can be run on container instances in three ways. It can be run as a service, which is suitable for stateless 12-factor apps. You can easily scale them and perform blue-green deployments. And these tasks are scheduled on container instances that have available resources. We can also run tasks as a batch job. For example, I run database migration command as a batch job. This task will also be scheduled automatically on a free container instance. And then we can also run as a task which requires persistent data. So it always needs to be placed on the same container instance since it has mounted volume on that host machine. You will see that right now when I will talk about issues. So, okay, sorry. All right. Okay. Well, the first issue is that Amazon ECS doesn't support Docker Compose. Well, it does, kind of. Amazon has actually created an ECS CLI tool, and you can define task definitions in YAML format, the same as Docker Compose, but it's lacking a lot of features and it's actually not compatible with Docker Compose format. Well, this might improve over time. So, how do we configure an ECS cluster? I started off with CloudFormation template, which I found to be quite hard to maintain, and I came across some limitations, which I can tell you about later or at the end. It's not so important. Well, I've also read Damjan's blog around Terraform and Consul, and Tomaz advised me to try Terraform. I found out that it's a really great tool. It's very flexible and easy to use. So, no volume plugins, which means that we can't use Rexray or Flocker for some kind of network storage. So, how do we overcome this problem? Well, we don't. We can use S3 buckets for static and media storage, and we can place containers which need persistence on specific container instances. For example, if we want to deploy Redis container, we always have to deploy it on a specific instance where that volume is mounted. Okay. The official documentation says that containers can communicate with each other through container linking, which I already mentioned that is legacy. So, the problem is that, as you can see, in one test definition, we can specify maximum of 10 containers. What happens when you need more containers? How can these containers communicate? And also, how do we scale a service which requires access to Redis container? Well, we surely don't want to end up with multiple Redis containers for each web application. So here is where I use Consul to solve the service discovery problem. And I will show you later how I configure everything up. The funny thing is that currently CloudWatch logging driver is not supported, even though Docker already supports it. So it's quite an irony that Amazon don't support their own driver. And another problem is that some features are not available in some regions. For example, Elastic Container Repository is currently available only in America. I think that in North Virginia region or something like that. And now we'll move on to cluster configuration with Terraform. Well, I actually use multiple Terraform modules for multiple environments. I have a VPC module which configures VPC along with some routing and other stuff. And I have ECS module which configures ECS cluster, EC2 instances, Elastic Load Balancer, and security groups. And I have RDS module for database as a service. So here you can see how these modules look like, how I configure them. But more, I will show you more when I show you my project structure and how I set up everything up. All right. Okay. On Amazon ECS, I'm actually running 3 ECS instances for high availability. I have 2 auto-scaling groups. One is for Consul server, and the second one is for Consul agents. Infra instance is used to bootstrap Consul cluster. Each instance is running a Docker daemon, ECS agent, Consul server/agent, which depends on auto-scaling group that we're using, a registrator, and a C-advisor, which is used for monitoring. We could also use Prometheus to aggregate monitoring data from all container instances. I'm actually using official ECS MEI, where I have modified the init script, which passes Consul IP as a DNS server argument to Docker daemon. This way, Docker containers can discover each other. And I also use Amazon ECR for private Docker registry, where I can then pull images and everything else. Container instances can be launched across multiple availability zones, and I have defined 2 services. Nginx service puts Nginx containers behind Elastic Load Balancer, and web app service scales web app containers to a desired count. Web app containers are load balanced by Nginx. Consul template can reconfigure Nginx when a new web app container is launched and adds it to a set of upstream servers. We could also use another elastic load balancer for web app and use Nginx only as a router, which is probably preferred solution. Nginx also exposes containers with predefined tags on a subdomain, which is useful for monitoring apps such as Redis container and management apps, of course. I will show you this a little bit later when I'm going to deploy Redis along with Redis Commander. Here you can see the elastic load balancer, which is balancing between Nginx tasks. These Nginx containers are placed on every node, in my example. And each Nginx is load balancing between our web applications. Well, I've just made some playground to test and to play around with. The next important thing here is that I'm using a registrator. Ladder Labs registrator automatically registers containers in Consul as a service named after service name environment variable. Here you can see the task definition that Amazon uses for Nginx. And you can see that here I have defined our Nginx container, which is pulled from our private ECR registry. We can also set memory limit for that container, and we could also set how many CPU units can this container use. Here I have some logging configuration. Just for example, I'm using JSON file and some kind of log rotation. Here are port mappings and of course our environment variable. So when we deploy our Nginx container, registrator will pick it up and register it as a service inside Consul named Nginx. Okay. So, Consul. Here's the image of Consul UI, and I'm running 3 Nginx services on 3 different nodes. On the left side is part of my Nginx configuration, and you can see that I'm using Consul template to configure a new upstream when a new service is added. It's the same thing that Tomaz showed earlier. I mean, it's similar. And the last thing that I want to tell you about is Empire. Empire is a control layer on top of Amazon ECS. It's open source and self-hosted. Developers say that it's suitable for small to medium-sized companies, and I think that it's worth checking out, though it has some limitations and you won't get the full flexibility that you can get if you're working directly with the ECS. Another thing to consider is using Docker Swarm on EC2 instances along with other Amazon services. Well, this might be a good idea for large projects, but you will have to manually configure your Swarm and manually handle your Docker upgrades. You will have to take care of certificate management, and you have no access control which you can get with Amazon. So the main benefits are that you can use standard Docker tools, and you get latest Docker features if you upgrade to the latest Docker version. So that's it around that. Now, I don't know what's best. It's probably best that I show you some practical stuff, and then we have some discussion around this. All right. So, first, I'm going to show you my project structure when I'm deploying a simple bootstrap project to the ECS cluster. So
just probably it's too small for us.
yeah, I can resize the right pane, but I don't know how to resize this one. Okay, so you don't see anything over here, right?
Resolution?
Yeah, I've already tried it, but without success. Okay, I will show you the Docker Compose file that I'm using for development. So I'm defining a couple of containers and some utility containers. So I'm actually deploying a Django application where I have manage command and npm and pip, so we can just say docker compose run pip install, and you say the name of the package and container will run and install that pip package. So yeah, as you can see, I have a lot of utility containers which help me with my work. And yeah, I of course have Celery, some monitoring tools, RabbitMQ, Redis, Postgres.
Sorry, can you increase the font?
Yeah, sure. All right. Yeah, that's too big. Something like that. Yeah. So, as you can see, we can easily add a new container here. If we need another database, we just need to add another block and do a little bit of configuration, and that's it. So to deploy, to start a RabbitMQ server, you only have to add this block. So this is what I was talking about when I said that development with Docker is easy, and it's also fast. So previously I've been using Vagrant, and I've been having issues when Vagrant was syncing the node modules on the host machine, because as you know, node modules is a huge folder. There are a lot of files, and because of virtual machine, everything gets slow. Well, I've resolved this with the Docker because I'm selectively syncing some files and folders, so I actually don't sync node modules and other folders which are not necessary. All right, so this is regarding the development. We can also check how does the Terraform configuration looks like. So, as I said, I have 3 modules: ECS, RDS, and VPC. And yeah, I've of course configured all of the resources that I need to bring up the ECS cluster. You will have to manage your security groups, auto-scaling groups, launch configurations, and everything else. So it takes some time to start with everything. You will have to define your infrastructure. But here the most interesting part are the init scripts. So when a new EC2 instance is launched, following init script is launched, and it actually stops the Docker daemon and passes a few additional arguments to Docker daemon. So with this, we enable the service discovery. We pass in the IP of our Consul server. So yeah, and here I start few containers. This one is for starting the Consul. The second one is for registrator, and the last one is for cAdvisor. So this is for our server instances. I'm of course defining a load balancer and the infra instance, as I mentioned earlier, which is used to bootstrap the Consul cluster. Here I have some security group settings, configuration. So yeah, there's a lot of configuration around Amazon ECS, but once you get it right, it's really easy to work with. The next thing that you're probably going to get scared of are shell scripts. As you can see, I've defined many helpers to make life easier. So I split up my my commands in several files. So each of these files performs its own task. For example, with this one, we deploy our image to Amazon ECR. This one serves as for service deployment. The next one is for test deployment. We can also run batch jobs with run task. And yeah, these files actually reuse each other to make workflow easier. Hub folder is used for our custom containers. Here I'm defining our Nginx container, as I mentioned earlier. This one is using the Consul template. As you can see, it's defined here. So again, a lot of configuration. And inside here I have my source code for my Django application, and inside tasks I have task definitions. For example, today we are going to deploy our Redis. So this task definition contains two containers. One is Redis and the second is Redis Commander. And as I said earlier, we are going to expose Redis Commander on a subdomain. As you can see here, it has HTTP tag defined. This tag is picked up by our Consul template here. Just a second. So you can see that I'm checking for these tags over here. So when this container is registered with Consul, this section will be added to the Nginx configuration. So these are actually the basics. And now I will show you how we are going to deploy our Nginx container and our Redis container. So just a second, I think that it's over here. So yeah, I will call my my script for service deployment. I'm going to tell it to which cluster I'm going to deploy to, which service I'm going to use, and which task definition from the task folder I am going to use. This is actually the image that is going to be pushed to the ECR repository, and we are going to build from this Docker file along with some build arguments. Well, let's execute that. So you see that this Docker, this image got built here, and now is going to be pushed to the ECR repository. All right, it was pushed to the ECR, and now we are actually deploying our Nginx service with a new revision. So how do we update our service? For example, we have our web application and we have deployed it as a service. So when we make a change to our code base, we will actually need to push a new image to the ECR, and we will need to register a new task definition. So as you can see for here, if I do another push, this number will increment. So we register a new task definition, and the service will get updated. Just a second to show you what's happening on the ECS. Where's my Chrome? Just a second. Well, did I close it? All right, I will open it again. All right. So here it is. So I'm running a cluster with 3 container instances, and our service should be now registered over here. If we refresh this, we should see Nginx, which we just pushed. And as you can see, I specified that I want 2 Nginx containers running. So if we check, it was successfully deployed. So we are running 2 Nginx containers. I mean, on ECS, these are actually called tasks. So I will show you what this means. All right, here I'm logged into one of my container instances. Just a second. All right. Can you see this? Is it big enough? So here is running our Nginx container, which we recently deployed. And I will show you how does the Nginx configuration looks like. So if we say docker run, docker execute, this one, cat. So, as you can see, well, this was generated from our Consul template. As you can see, cAdvisor is automatically registered and exposed on our subdomain. As you can see, I've used an example domain here because I don't currently own any domains. Here we have the Consul UI, but I cannot access it because I don't have a real domain. But now I'm going to push Redis container to the ECS, and you will see that Nginx configuration is going to change. All right, here, second. So we are going to deploy a new task on BS project cluster. This task is named Redis, and we are going to place it on a specific container instance. So I've already mentioned that we have three types, three modes which we can use. So we can deploy services, we can deploy tasks on specific instances, and we can run batch jobs. And here we are going to deploy a task on a specific instance. And of course, why is this useful? Because Redis has some persistent data, and we always have to deploy it to this specific instance. As you can see, new task revision was created, and now it's waiting for the running status. As you can see here, what's happening. Okay, it already started on our container instance, and what happened now is that our configuration should register our Redis container here. As you can see, Redis commander container was registered over here, and it's put under password and username, so only we can access it. And if you remember, when I pushed the nginx container, I provided some build arguments to specify which username and password I'm going to use. All right. What else? Where's my Chrome window again? All right. So now we're running 2 nginx containers and Redis. Again, these are not containers, sorry, tasks, because a task can contain multiple containers. If you check it here, you see that this task actually defines 2 containers, Redis and Redis Commander. Well, I think that's about it. I can also show you that Consul is working, so we get the service discovery. I'm going to execute this command. Just a second. I have to check the IP. All right. So one. You can see that Redis Commander is actually running on this IP. So as you can see, Consul is actually working. So if we check for the nginx service, we're running 2 nginx containers. You'll see that it's present on both, on 2 nodes. Questions? Yeah.
So I didn't quite understand, how does the Consul template get rendered into the file of nginx?
I will show you this right now. I run, just a second. Here I actually run our shell script. Just a second. Here I've downloaded the Consul template and configure it. And then I execute the template shell script, which actually stops nginx and renders a new config file, and then it brings it up again. So it reloads the configuration. So here we define, this is from the documentation. You can check the documentation of Consul template. So we are going to use this source file, which is actually a template, and then we are going to render it to this specific destination. And when this happens, a restart shell command is run to actually bring up the nginx again up. Did I answer your question?
Thank you.
Okay.
I have another question.
Yeah.
So before you were saying that the Docker link parameter is deprecated.
Yeah.
But what about in the situation when you have IP tables set up and you disable inter-container communication? This means that IP tables set up drop rules for everything, and you need to explicitly allow them. The link is used for this case.
I don't know about the ECS, but now Docker by default uses DNS-based discovery. So
yes, but if you turn off inter-container communication, then there is a firewall drop rule that drops everything.
yeah, I guess I haven't tried that. I can't answer that. Sorry.
Maybe just another question.
Yeah.
Have you tried any other container deployment and orchestration system?
Yeah, I've been working with Docker Swarm and with Tutum, I mean Docker Cloud. But yeah, I didn't try Google or Apache Mesosphere or anything else. Well, we use Amazon, so I've invested all of my time in this infrastructure. Yeah.
I have a question. This looks like a lot of moving parts.
Yeah.
How much time did it take you to build all of that? And secondly, what's the timeline that you built? You probably didn't start with all the moving parts. Was the, I don't know, first 2 or 3 that make something useful, and how did that?
Well, it took me around 2 weeks, to be honest, to get the basic infrastructure up. But yeah, first I had to, I needed to learn everything, how everything operates. And the second question was?
So how did it evolve? What did you start with?
Yeah, I actually started with CloudFormation template. I found a very interesting blog where it's described how to use Consul on Amazon ECS. And they provide a CloudFormation template. But yeah, I soon realized that this is not going to do it. So I've rewritten CloudFormation to the Terraform. So I guess that it took me a few days to come with this structure. But the nice thing here is that if you check here where I configure my modules, I can just duplicate this configuration and configure it for staging environment. So we can simply create another VPC and ECS and RDS, which is used for staging.
One question.
Yeah.
Can ECS use any of the other existing Amazon services?
Yes.
Running Redis in a container is just like blasphemy. It should be persistent.
Well, here I'm using RDS. I'm not running Postgres in container. Okay. So I guess if it's available, you can configure it. It's not a problem. You would just have to add another module to the Terraform. Yeah, this is a playground, so it's going to improve and yeah, over time. Anything else? Okay.
Thanks. So I'll just quickly show one thing, not even like show it, but right. So I did this blog post, and the reason why I'm showing you this is because in it I actually did a Terraform console example, which means that you can check out this, change the credentials to your AWS keys. You can learn, you can like type Terraform apply, and it will set up a Consul cluster, and you can basically see how it works. The end result is basically after the run, you get Terraform, you get a Consul UI, and the whole cluster basically set up, nearly production ready. You just need to remove the all access on the security groups. So that's it for today. Thank you very much for coming. We need to thank Peter from vŽIVO who streamed it. So vŽIVO is a sponsor, and also D-Labs is paying for the drinks. So let's go there and chat some more if you are willing to share something. So yeah, that's it.